Is another way to simplify a problem. If you have a problem, and especially as the problem gets bigger, you don't want to sit down, look and see, oh, this common with this common with that, this, and that. There's an easier way to simplify. It's called the K-map. A lot of people don't call it the Carnot map. They call it the K-map. And this is the engineering way of simplifying things, or the computer science way of simplifying things. Now, if you only have two variables, you can do it by hand. It's not that difficult. Two variables, there's only color options for that expression. So you don't need the K-map. Where the K-map comes in when you have 3, 4, 5, 6 variables. You don't want to have an expression that big and try to simplify it. So for example, if somebody came in and says, well, we have this function f of a comma b. I'm not going to simplify. Well, I'll do it. A, B, and C. And it's the summation of the min terms of 1, 2, 4, 5, 7. Can you simplify that? Well, right now, the only way we know how to simplify it, we go, well, let's see what that expression is. Since that's the sum of product, this is sum of product, that tells you when the function is 1. 0, 0, 0, that's the function is 0. 0, 0, 1, the function has a value of 1 at 1. 0, 1, 0, the function has a value of 1 at 2. 0, 1, 1, the function is, that's 3, that's 0. 1, 0, 0, that's 4, it's a 1. 1, 0, 1, that's a 1. And 1, 1, 0, that's a 0. And 1, 1, 1, that's a 1. So 1 at, this is the 0, the 1, the 2, the 3, the 4, the 5, I forgot to put a line here, 6 and 7. It says you have a value of 1 at 1, at 2, at 4, at 5, at 7.
Is this the SOP?
Well, you can do SOP and POS off this one. So if you want to write the sum of product here, the SOP, that's the min terms, you can say, well, to have a value of 1, that's when this is 0, 0, and 1. So it's A bar, B bar, C. That's this one. Plus this one, A bar, B, C bar. Plus you have a value of 1 at 4, which is what? A, B bar, C bar. Or at 5, which is what? A, B bar, C. And at 6, which is, nope, at 7, which is what?
A, B, C.
A, B, C. And now you try to simplify it. And if you were trying to simplify it, it just happened to be by luck the way I wrote this one. Notice these two. What do they have in common?
B bar and C bar.
So if you factor B bar and C, what's left? A bar plus A, which is what? 1?
Mm-hmm.
Let me write the rest of it. One of them is not right. I think that's the 4. Oh, that's the 5. I'm sorry. That's the 5. I got it. Yeah, it's right there.
Oh, you can do
Yep.
the x plus y equals x plus y naught with a bar b.
Which one you want to do?
A bar b c bar plus
A bar,
a b bar c.
A bar, B, C bar. This one?
Wait, can I write it? I must have written.
Which one you were looking at? Okay, go ahead.
Yeah, you could take.
Bless you.
First and the third.
Notice, by the way, I could have wrote this twice. See this one here? I could have added it one more time. You can write the same term as many times as you want to. So if I added one more time right here, enter that one, what will happen to that group there?
It becomes
Becomes what?
C bar plus B bar B, which is 1.
So that's AC.
We can combine the first and the third term.
Sure.
Don't forget to add that bar to C.
Yep, thank you. Well, if you look at, oh, that's what is that what you're talking about, Dave?
Oh, yeah.
Combine these guys? Okay. Dave said take these guys as B bar. What do you have? C plus C bar A. X plus X bar Y. This is actually C plus A. Which you can open it to what? B bar C plus A B bar. Let's bring the rest of it. We have A bar B C bar plus AC.
Now, can you get any more simple than that?
Now I'm looking to see. And probably, maybe not.
You could do, you have B bar C and AC. And
B bar C.
times B bar plus A, but I don't know if that makes it more simple.
I don't see anything unless I'm blind. It looks like that's as far as I can go. Maybe I'm blind, but that's all I see. Now, I could have done this with the K-map 10 times quicker and easier. Let's see how that is. We're going to do a 3-variable K-map, and let me look at your book, and your book does them horizontally. I can do them vertically, horizontally, it doesn't matter. So, since we have 3 inputs, notice how many choices do we have? 8? So the K-map, I said vertically or horizontally, it doesn't matter, but this is what our book does. They lay the K-map horizontally. They have 4 layers on the top, 4 columns and 2 rows, that's 8. And they label them A, B, the most significant, and C is the least significant.
How do you
No.
know that?
You can label them anyway, but that's how they label them, and the reason they want to label them that way is so you can go 0, 1, 2, 3, like this. If you label them A and C, that would be 0, 1, 2, 3. And the key to the K-map is you want to make sure all these are adjacent. What does that mean, adjacent? They can only be different by 1 cell. So if you look at the address for the top, watch this. This is 0, 0, 0, 1, 1, 1, 1, 0. They have to be adjacent. Adjacent means they can only be different by 1 cell. Any way you look at it, and this is 0, 1. So the address for this is 0, 0, 0. The address for this is what? 0, 0, 1. The address for this, 0, 1, 0. The address for this, 0, 1, 1. The address for this is what? 1, 1, 0. 1, 1, 1. 1, 0, 0. 1, 0, 1. So basically, let me number them here. This is location 0. This is 1, 2, 3. That's why I label them that way. 0, 1, 2, 3. 4, 5, 6, 7. 0, 1, 2, 3, 4, 5, 6, 7. Now, let's look, grab them any way you want to, adjacent. Look at these two. How are they different?
By 1.
How about these two? When you flip it, just picture that paper also wrap around like this. You can wrap it like this. If you wrap it, how many digits are they different by?
1.
1. Thought I heard it focusing. Look at these two. How are they different? By 1. These two. By 1. These two. By 1. This and this. By 1. This and this. By 1. If you fold it this way. This and this. By 1. So the difference between any one of these cells is always a 1 digit. Now, let's go back to that K-map and put where the ones are.
So like how is this box like tailored to our problem right now, or is this like a
You
general?
get, nope, that's for any problem. You'll see how we're going to solve it now.
So you flipped over the 0, 0, it became 1, and then you flipped it over, which made it 10 to get that 11 back to 10. I'm looking at AB on the top.
Yep. 0, 0, 0, 1, 1, 1, 1, 0. Now, again, this is location, just to make it easy for now. This is, I'm going to write 0, 1, 2, 3, small writing, 4, 5, 6, 7. The problem we just finished doing, what was it? The summation, the midterms are where? 1, 2, 4, 5, and 7. Let's go to these location, put ones in them. Location 1, there's 1. Location 2, there's 1. Location 4, there's 1. Location 5, there's 1. Location 6, nope, location 7, there's a 1. Right? That's where the ones are. There's a 1, 1, 1, 1, 1. The rest of them means zeros.
Why do ones zeros?
That's the midterm. That's when the function is 1. Now, here's what we do to simplify an expression. You need to look for groups of either 2s, 4s, 8s, 16s. The bigger the group, the more simplified the answer. So 16 is better than 8. 8 is better than 4. 4 is better than 2 if you can. 2 is better than 1. So look for, is there 4 adjacent ones next to each other? It has to be in a row or next to each other.
No.
No.
Is there 2 next to each other?
Yes.
There's one of them.
And then also 7 is.
And then there's another one. Let's see how we read this. When you read this one, up and down here, notice A is always 1, B is always 0. Never change for that group. The only one that changes is what?
C.
C. That means it doesn't really matter. If C is 0 or 1, you're still going to have a 1. So C is not a factor in this group. So your answer for this, for anything that doesn't change, the thing that doesn't change is A and B. A is 1, B is 0, so that's A, B bar.
So B changes.
No, B didn't change. A was 1, B was 0 the whole
Okay,
time.
okay.
C was changing for them. That's why C is not in the expression.
Got it. Because C was changing, you don't put
Yep,
it in.
because that means it doesn't matter. If it's 0, it's still going to have a 1. If it's 1, it's still going to have a 1. So 0 is not a factor there.
So the other one, it changes, right? Like the other way, like going
This one?
horizontally, yeah.
Now let's look at this group here. A went from 1 to 1. A never changed. So A is my answer. And if it's 1, you don't complement it. Look at B. B went from 1 to 0. It did change. That's gone. What about C?
C stayed the same.
C stayed the same, and that's AC.
Is that it?
Nope, because you still have the ones. You got to group
Does
these
say
guys.
there's more.
What about this one?
C stayed the same?
Well, with who? Can you?
Yeah, it wraps around to.
Yeah, grab around with this one. See this one? These guys are adjacent. If you fold that paper like this, they are next to each other. And what do we notice? A is changing from 0 to 1, so A is gone. B is 0, that's B bar. And what about C? C stayed the same, which is 1. And this one, can you group this with anyone else?
No.
Gotta take it by itself then. And since nothing's changing there, that's A bar, B, C bar. Let's see if that's the answer we came up with.
It is.
Hold on. Buzzer.
Yeah, wait.
Okay.
Do we have B bar C right here? Do we have A B bar right here? Do we have A and C right here? And this and this. The same exact answer, a lot quicker. Normally it takes me about 30 seconds to simplify the problem with this method. Let's try another one.
I have a question.
Yes,
Why is it AC and not ABC? Because it says
AC. Where's AC?
AC, the second term.
That's this group.
Yeah.
B is changing. Went from 1 to 0. Out. Yep. Anything that changes means not a factor. Out. Basically, if you look at it mathematically, you look at this term, that's what? It's A, B, and C.
Who came up with this? How did they come up with this?
I don't know, some smart person. Look at this. This is what? A, B bar, C. And if you do the math, what happens to B and B bar? Yep. So that's why if it changes, that means you're going to have B plus B bar. One is going to be 1, one's going to be 0. When you OR them together, what's that answer? 1? So that's why anything that changes, it says, oh, it's not a factor. The thing is, you can't have groups of 3s. It has to be groups of 2s, 4s, 8, 16. No 6s, no 12. It's always a multiple of 2, or power of 2. I shouldn't say multiple, power of 2. 2, 4, 8, 16.
As you move on, you mind just going over how you got B bar C from location 1?
B bar C. Oh, that's these guys, I think.
Oh,
These two.
You connected,
Yep.
connected 5 and 1.
Yeah, because they fold that paper, and those are adjacent.
So
Okay.
there's 3 of them, right? 3 in a row?
There's gotta be multiple of 2.
What do you mean, multiple?
No, you can't do 3. You can't do 3.
No, no.
You
Has
can
to-
do 2
4.
or 4.
2, 4, 8, 16 has to be 2 to the power of n. So if 2 to the 0 is 1, so it could be 1. 2 to the 1 is 2. 2 to the second, 4. 2 to the 3, 8. 2 to the 4, 16. So the groups, that's what you're going to be looking for.
I'm just trying to understand
Yeah.
how you got, where you have the 1, 1, and where you got that 0 from. The C equals 0, right? Where that 1, 1 is on the graph.
I have no idea where you're looking.
You know AB equals 11 on the top? Yeah. If you go 1 down, how you got 0 there?
Well, if it's not 1, what is it?
This graph is a different
The-
representation of
yeah.
the truth table.
Look up at the top. See here, there's the
So
sum
we're
of
looking
min.
at, like, that block right there is line equal to 6 on the truth table.
Correct.
Oh, okay.
Yep.
So
So
it
line
equals
6
because
on
it's
the
an
truth
and
table
it's
Yeah,
0.
line
Okay.
yeah, that's what this,
Block
yep.
is 0.
Okay, now that makes
So it's 0 because you only have 1, 2, 4, 5, and 7.
Then why is 2 1?
2 is 1 because on the top it says 2 is 1.
Ah.
1 is 1, 2 is 1, 4 is 1, 5 is 1,
Oh, yeah,
7
that
is
makes
1.
Those are the ones that
Yeah.
are positive.
Yep. Now, if you want to group the max term, the same thing, we group the zeros. We'll get to that shortly. Let's try another one. Let me take another one and try to simplify it. Let me just go to the end of the book and grab some examples. I don't have to make them up. I'll stick with the 3-variable K-map. That's called 3-variable K-map. In a few minutes, we'll jump to the 4-variable K-map. Too easy. Too easy. Let's see if we can find something challenging. Okay, here we go. Let's say we have H equals X plus Y Z bar plus X bar Z. X, Y, and Z. You can see 3 variables in it. That's X bar. Can you see the bar over it? Yeah. That's the 3-variable K-map. Now, X, Y, and Z. Normally, that's how we write them. So I'm going to say these are the most significant. That's the least significant.
It's least significant because you use less of it?
The value of it. When you write a number 123, which number is bigger in terms of value? That's the 100. That's the 10. That's the 1. Most significant, least significant. Again, the numbering 0, 0, 0, 1, 1, 1, 1, 0, 0, 1. Now notice how I'm going to jump to this. You're going to have a value of 1 anytime x is what? This is a sum of product. That means that tells you when the function is going to be 1. You're going to be a 1 if this one is 1, or this one is 1, or this one is 1. So when is x going to be 1?
What is it? One.
Which numbers?
The last 2.
The last 2 columns. We don't care about y or z. It says when x is 1, you're going to have a value of 1. So that's this column and this column. X is 1 here. This one says you'll have a value of 1 when y is 1 and z is 0. There's no mention of x. y is 1, z is 0. Where's y is 1 and z is 0? Z is 0 is this row.
So right.
Where is y equals
right
to 1?
Left of the first one. Right?
This and this. Right? I already have a 1 here, so I just add one more to it. And the last one says you're going to have a value of 1 when what? When x is 0 and z is 1. Z is 1 is the bottom row. Right? X is 0. Where is x is 0?
Both ways.
The first two? Okay. And now you're going to look for groups of 2s, 4s, or 8s.
Well, there's
See
one
group
four.
of 4
Which one is that?
along.
The bottom?
Yeah.
Okay. Now, if you look at that group there, it looks like x is changing as you go through it, right? It went 0, 0, then 1, 1. So x did change, x is out. What about y?
Y did not change.
Look again.
I did change.
Oh, why no?
Y went 0, 1, 1, 0. Y also changed. That's gone.
Z did.
So the only one that didn't change is z, and since z is 1, that's the answer for that one, z. Do we have another group of 4?
Yes.
Yeah. Vertical.
4 is better than 2.
Oh, you can do it like that.
Yep. So let's look at that group.
That'd be just X.
Well, x is 1. Y did change, right? Y is gone. Z did change, went from 0 to 1. So that's x.
And then you have the one, the.
We have that 1. We're going to include that.
So you can't overlap?
What do you mean overlap?
Because you have 4 columns in the middle.
Yeah, it can, sure. Is that what you mean by overlap?
Yeah.
Sure, that's a group of 4. And let's look at that group. What do you have? Looks like Y.
Then you have another overlap across.
That's you already used them. Once you use them all, you don't want to keep doing it because that's repeating stuff you don't need. So once all the ones are circled, you don't want to look, oh, I can do this and that. No, because if they're all circled, you're done. You know. So your answer is going to be that. That's actually your sum of product. It just happens to be it's only one OR gate. Doesn't look like anything because it's simplified to this. You group in the ones. Sum of product, you group in the ones. Product of sums, you group in the zeros. And if you look at that, the zeros, there's only one 0, right? So when you take the 0, you take it by itself.
That's X, Y, Z.
Will be x plus y plus z. And what do you know? Is that the same answer? In this case, it happens to be the same answer. So if you want the product of sums, you group the zeros, and the zeros, it's always product of sums. You have a sum. So x plus y plus 0. And it with if there's another one. I don't have any other one to end it with.
And if that was in another place and you had a 1 as one of them, you would complement it, like in the other?
If I had one.
Like if, say it was a different problem and you had just 1 0 alone in the next column to the right on the same row?
Here? Or here?
Um,
Oh, here, I mean? Oh, I see, like a complement of that? Yes.
you'd
Is that what
say-
you're asking? Yes.
So you'd say it was.
The one, you want to complement the one?
complement
Yep,
plus y
keep the
plus-
zeros, yep. I see what you're asking now, correct. Let's try another one. I'm just different examples, then we'll expand that to 4 variables in a minute. We have f of a comma b comma c equals the summation of the minterms 1, 2, 3, 6, 7. That's where the ones are. I'm going to give you both answers, product of sum, sum of product. A, B, and C here. Again, 0, 0, 0, 1. 1, 1, 1, 0. 0, 1. Let me write the address just in case you forgot. Small writing here. This is 0, 0, that's location 0. 1, 2, 3, 4, 5, 6, 7. Can you see these numbers? Small numbers, I wrote them intentionally. Yep. So that's the address of each one. You will have a value of 1 where? According to this expression. At 1, at 2, at 3, at 6, and at 7. That means the other ones will be what? These locations?
Zero.
Zeros. So that's what they're telling us. You're going to have a value of 1 here, 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 and there. So to simplify that, look for groups of 4s, 8s, 6s. There's no 8s. No 6. There's no 8. I see a 4 in the middle. And this, again, C is changing, so it's out. A is changing, that's out. What's left there?
B.
B. Plus.
You could do 1 and 3.
I can do 1 and 3. That's the only way I can do the 1. There's nothing else, this 1. I can either take it by itself, which is not a good move, because you want to simplify it. So this and that. And again, A is what? 0. Nope. See how A didn't change the first number? So that's 0 is going to complement that. A not. B did change. What about C?
C did change.
Did or didn't? Yep. So that's my sum of product. Notice you have a product and you're going to AND them. If I want the product of sum, I group the zeros.
So
You could do 0 and 4.
I can take these two zeros. Now this way you were asking, since I'm grouping the zeros, notice these two didn't change. C did change, so C out of the picture. But since A is 1, I got to complement that. That's A naught plus B.
why do you have to not A?
The one, because you're trying to group the zeros.
Oh.
That's an OR gate. You want it to be 0. The only way to be 0 for an OR gate, if both of these guys are zeros. So when you make a gate like this with A naught, when you put a 1, 0 through it, you complement the one that's 0 or 0, which gives you a 0. And what about this and that?
Yeah, you could do that.
I can take these two together, and that will give me what? Let's see. A is changing. It's out.
B doesn't change.
B doesn't, has a value of 0. That's good. No complement is 0. And C doesn't change.
Now isn't it B not?
Nope, it's
Oh,
0.
because it's 0. So
Yep.
it should be.
So this is the product of sum. This is the sum of product. That's your min term. We call them min terms. These are called your max terms. I know. Well, size-wise, it looks like, yeah. But they call the zeros max, so maybe it should be 1 max, but we engineers, we think different, yeah?
I can see maybe they took a max terms because it's a longer equation.
Nope, because it changes from problem to problem. It's not always the case. What he's saying, because there's going to be a value of 0, and that's a value of 1, we should give the 1 the max, 0 the min.
Well,
Make-
the first one is 2 gate, and the third.
Well, it changes. That's not, because we don't change the name just when we switch to different problem. So in this example, you're right. It just happens to be 1 and 1 OR. This is 2 ORs, 1 and, so that's an extra gate. But that's not always the case. But so I don't want you to think max always have more terms. No. What Henry's saying is, like, if since this is the group of the ones, the zeros, and that's the ones, 1 is bigger than 0, they should have called that a max, and this is the min, but that's what they call it, and we got to live with it. Okay, let's try another one. Do I have another one? One more. I think you got this one. Because once you get this, the 4 by 4 is the same thing. The next one is making sure it's not a homework assignment. That's what I'm looking at. Because I don't want to do the homework for you.
Why not?
I'll spoil the fun for you. 0, 1, 2, 5, 6, and 7. Again, if you take the time now and just go and write the labels here, by the time you leave the class today, you'll know them. This is 0, 1, 2, 3. I jump over that, 4, 5, 6, 7. So I have a value of 1 where? At 0, at 1, at 2, at 5, at 6, at 7.
I'd say if you want to do like just the easiest, I would do 0 and 1 as a group. Right?
Well, are you gonna add the zeros?
I could. Notice I could have two different answers for this. Let me do it again. I want to show you sometimes when you do the problem, I do it and you do it, we have two different solutions. The same problem. So you said do this,
You do that and then
Do this?
Yep.
and do this.
Yeah.
Okay.
That way you can get them all done. You don't have to worry about overlap.
Okay, let's see that. So now when you look at this, C is gone here. What do we have? A naught, B naught. This one here, C is not changing. So it's going to be part of the answer. A is changing. See, A went from 0 to 1, but B did not. So it's B, C naught. And what's the last one?
Well, C doesn't change, so.
That's there. C is there. And A doesn't change, right? Now, I'll be honest with you. I didn't see that. Well, I mean, I wasn't thinking that direction when he did it. I was thinking taking this with this, taking this one together, taking that one that way.
So like the way they set up the columns for the table, is there a reason for that?
Yeah, because you want to be adjacent.
Like if you switch the last two columns.
Can't. Then they're not adjacent.
But you
0,
would have a
1,
different
1,
answer.
0. They're different by 2 cells.
But you get a different answer though.
Yeah, but still the same number of gates. It is different answers. So that's what I'm saying. Sometimes when I do the problem, I have a different answer than yours. That doesn't mean I'm right and you're wrong, or you're wrong and I'm right. I think I said the same thing. I said I'm right, you're wrong, and you're wrong and I'm right. Still I'm right and you're still wrong. I like that answer.
Can't do it.
So you can go either way. So this one here will be what?
C
A
doesn't
naught.
change.
C naught, right?
Yeah.
I don't have that there. This one here will be what? AB. And the bottom one is going to be what?
C.
No, B, yeah, B naught C. So it's really the same number of gates. It looks different. Notice here A and B were complement. So you still need 2 NOT gates for A, B, and C. You still need A, B, and C NOT gates for them. You still need 3 AND gates. 3 AND gates the same size. You still need 1 OR gate. So in terms of gates, it's the same thing. But again, it depends which one you group or which ones. It could make your answer look different, but it doesn't mean it's wrong. So it depends which way you grab it.